Okay, so in the last video we introduced a new NIM module called the SCA, the Single Channel Analyzer. And as we discussed, what the SCA allows you to do with the lower level knob and upper level knob, it allows you to set a voltage window. And if a voltage pulse comes in like that, and at some point the voltage goes between these two voltage levels, the SCA will react. Now, react isn't a great word, but let me just tell you what react means. So now we have the output of the SCA down here connected to channel 2 of the oscilloscope going in right here. So let me go ahead and turn on channel 2. And if I do that, suddenly I see on the oscilloscope screen here, I see some green pulses appearing up here. That's channel 2. Okay, so if I sort of wiggle this knob for channel 2, you see that's channel 2, and channel 1's down there. Maybe I'll make channel 1 a little smaller to get it out of the way a bit. Okay, there we go. So we see sort of a train of pulses on the top there. Now what those pulses are, those are square pulses. Known in electronics as TTL pulses that go between 0 and 5 volts. And that is the SCA's reaction. So the way the SCA reacts to a voltage coming in is if the voltage is between that window that we set, the SCA will send out a pulse. If it's not within the window, it won't do anything. And so it looks very noisy at the moment here. Let me change the display again. It looks very noisy. There's a bunch of pulses all over the place. But that's because if I go over to the SCA here on that lower level knob, this knob right here, I have this knob all the way down. It's the lowest level. So literally, that knob is kind of like the oscilloscope trigger over here, taking the oscilloscope trigger and setting it all the way down there like that. See how the oscilloscope just looks like a mess? That's because you're triggering on all the noise and all the little wiggles that are really close to 0 down there. So invariably, when you lift the trigger out of that noise, then you get the cleaner signal that you want. So the oscilloscope is unfortunately set all the way down, and so of course the green pulses that it's trying to put out are kind of a mess as well. So again, there's no relation between the oscilloscope trigger and the SCA's lower level discriminator setting, but they're very similar conceptually. So let me start raising this level by just turning this knob up, and let's see what happens on the oscilloscope screen. So I'm turning it. See, it gets a little cleaner, turning it. And now suddenly it actually looks kind of orderly. And so what do I mean by that? It may still look like a mess to you, but of course these are all those different voltages coming in from the amplifier, and they come in at different times. And so every time one of these pulses comes in, it's going to be above this lower level here, because this lower level I've raised it off 0, but it isn't that high. And so all of these pulses, or most of them anyway, will definitely exceed the lower level of the SCA, so the SCA will trigger. Let me show you how it looks one pulse at a time. So if I hit this single knob over here, there's one pulse and one SCA output. Another pulse and an SCA output. Another one, and another one. Another one right there. And so you see like the SCA pulse moves around a bit because the gamma ray pulses from the amplifier don't all arrive at exactly the same time, and it takes some time for the SCA to do its business. But you can see every one of the pulses that's above the internal level, lower level that I've set on the SCA, generates a pulse. And as I said, the oscilloscope on channel 2 is set at about 5 volts per division, so it's a 5 volt pulse. We can nail down the time though. If I move it over just a tad bit, it's a 5 volt pulse lasting about 500 nanoseconds. So it's a 5 volt, 500 nanosecond pulse, telling the downstream electronics that the SCA has decided then that this gamma ray pulse satisfies, it's above its lower level, below the upper level, and so the SCA reacts and that pulse comes out. So let me just show you also what happens. Let me run the oscilloscope then. What happens is we make the lower level too high. So I'm going to go back to this knob over here and continue to turn it up. So up it goes, and see the pulses, those green pulses are getting fewer and fewer and fewer because I'm discriminating out all of those pulses that are not of sufficient amplitude. It's almost like turning this oscilloscope trigger knob way up like that. Same kind of thing. Let me keep turning it up more and more and more and more. They go way up. See, eventually the pulses just disappear. Now, why would they do that? Because every single pulse coming into the SCA right now is below that lower level. The lower level is all the way up high, so there's not a single pulse that comes in that meets that criterion of having that lower level that high. But so as I start lowering it again by turning the knob down, we should see that green pulse appear again. And indeed, there it is again, indicating a pulse that has passed through the window of the SCA. So typically the way I'm going to use it at the moment here, I'm going to turn the low level all the way down, lower levels all the way down, and the pulses look like a mess. Now I'll raise up just a little bit to get out of the noise, and I'll just kind of leave it there. And so I'm pretty sure now that I'm out of the noise, the stuff that exists way down at the bottom right there, and just sort of leave it like that. I get one pulse, one green pulse from the SCA for every one of these yellow pulses that comes in from the detector. one pulse like that every time. Okay. And so I could also mess around with the upper level a little bit, and that's sort of the knob up here. So what I'll start to do, let me just turn that upper level all the way down. So what that happens is really puts a squeeze on those voltages here, something like that. They all disappear because now probably what I've done is I have one level right here and one level, the upper level right here, and maybe they either look like that or even the upper level is below the lower level, and nothing can satisfy that, so all the green pulses are gone. So typically then I'm just going to open up that upper level, open it up all the way once again, and only do my discrimination based on that lower level setting. So I hope you see then what the SCA does. It gives a go or no-go signal in the form of a TTL pulse, a 5-volt TTL pulse, if a voltage rises above a certain level and stays below another level. If it's in this region right here, the SCA will react. So what it allows us to do is set some discriminator settings on whether we'd like to react or respond somehow to a pulse coming in from the amplifier. And that's what an SCA does, a single channel analyzer.